All right. We are going to take a look at what we are now going to do with all this factoring and everything we've done. So these next couple of videos are about solving quadratic equations by factoring, right? So the whole point of factoring is to get something in a form where we can do something with it to achieve some kind of result, not just a factor for factoring's sake, because while it looks nicer when something's factored, I think, it doesn't really do anything, right? You can leave it in its original form and it's fine. But with this thing we're going to learn about now called the zero product property, all right, which is this really kind of intuitive and cool thing, and once we introduce it to you, you'll be like, oh yeah. With that, you realize then why we have to factor, why things do need to be factored, right? So we're going to explain that to you, show it how it works, and then we will have some practice examples. All right, so let's get going. And this coincides with lesson 3.4. Okay, so the zero product property says for any real numbers, A and B, if A times B equals 0, then either A is 0, B is 0, or both A and B equal 0. So let's just look at a regular example. First of all, if they're saying, okay, so if you have something that equals 0, right? And let's say we're multiplying 7 times something, and we know that the result is 0. If I multiply it by 1, right, we're going to get 7, right? If I multiply it by 2, we'll get 14, right? Well, then if I multiply it by negatives, we'll just get negative numbers. And even if you multiply it by 80 fractions, like, something like that, right, you're still going to get 7 1,000ths. You won't get 0. So the only way you can get 0 multiplying by something is if 0 is part of it. That is the only way you can do it. So it would have to be like that, right? Or you could have 0 over here, and you could have, another number over here, say -3 or something like that, right? But that would also equal 0. I always call 0 like the the magic eraser. Like it takes care of things, right? It wipes it out, right? And then the other option you have, and this is the third option, is that both terms are 0, right? Which happens. But in order to get a product of 0, right, in order to get the result of a multiplication problem that equals 0, one of the terms has to be 0. And that's just all there is to it. That is the zero product property, right? So like I said, kind of intuitive. Most of you are probably like, duh, right? But if that's, we need to talk about that. So now when we look at something with polynomial expressions, right, when we have it factored so that we have a product, because this right here, whether you realize it or not, is a product, right? If you've got a parentheses of something multiplied by a parentheses of something else, that's a product, right? It doesn't matter what's in the parentheses, right? You could have giant expressions in there, but it's a product. So because this is no different than writing this, right? So then if you have something that's like this, like above, right, that is also a product, right? And it's the same thing where you could have 1 equal to 0, right? So x plus 3 could be equal to 0. Or x minus 5 could be equal to 0, or both, right? So these are the three cases that you can have in with a polynomial expression, right? When you have a factored trinomial, right? Which is what we've got right here. So what's great about this now is if I know this, I can solve for x. I know how to solve these. These are very solvable, right? If you have x plus 3 equals 0, you just do what we normally do, and we're going to move the 3 over to the other side to get x by itself. We're going to subtract it from both sides, right? And then you get x is equal to -3, right? So that's one of the roots. That's one of the zeros, one of the solutions, whatever you want to call it. That is one of the solutions to this equation right here, all right, to this factored equation. All right, and we can call it an equation now because there's an equal sign. Right? It's not an expression anymore. It has become an equation, right? Same thing with x minus 5. You got x minus 5 is equal to 0. You add 5 to both sides. Remember, you're always doing the opposite, right? And then you get x equals 5. So I've got two solutions now, right, to this, which makes sense because we're talking about something that looks like this, right? And it goes through the graph. And according to this, right, it goes through the graph at, you know, -3 and 5, if you remember that from graphing, right? And so this is a much faster way to get this information, right, is factoring it and doing this. And then as far as both goes, well, if they're both 0, we know what it takes for both of them to be 0. So my solutions for this would be x equals -3, 5. Sometimes you'll see it written like that. Okay, so these are the zeros or the roots of this equation, right? And we can get to it by just understanding that when two things multiply and equal 0, that one or the other needs to be 0 or both. Okay, so that's the whole going to be the whole focus of why we factor, and then once it is factored, getting to this final answer. Okay, so hopefully this will make some sense to you guys, give you a little more practice with factoring for those of you who need it, and moving forward, you'll be in good shape. All right, so there's going to be a couple more videos on this with just some examples.